Hi everybody. Hi everybody. Myself Professor Pushpayan Avanti. In today's video, I am going to covering the sessions 53 and 54. That is the factor affecting the surface tension and also the viscosity, that is the streamlined and turbulent motion. So already in last video, I have explained about the surface tension. There is a surface tension definition and explanation of the surface tension on the basis of the molecular theory, surface energy and angle of contact. See, the factor affecting the surface tension. So here the surface tension is nothing but a property of a liquid surface. It will be displayed by its acting as if it is a very stretched elastic membrane, or it's a property of a liquid by virtue of it acts as a stretched membrane, or it can be defined as a force per unit length. And this phenomena can be observed in the nearly spherical shape of the small drop of the liquids and of soap bubble. Because this property, certain insects can stand on the surface of water. Already I have showed in last video that is a stride, that's a water stride. Water stride means they can stand or they can walk on the surface of the liquid. So surface tension depends mainly on the forces of attraction between the particles within the given liquid and also upon the gas, solid or liquid in contact with it. The surface tension can be expressed by formula, that is force per unit length, that is a force by length. So impurities present in a liquid appreciably affect the surface tension. A highly soluble substance like salt increases the surface tension, whereas soluble substance like soap decreases the surface tension. So there are the two factors which are affecting the surface tension. There is the temperature and also the impurities. The surface tension of a liquid decreases with rise of temperature. The surface tension of a liquid is zero at its boiling point and it vanishes at a critical temperature. At critical temperature, intermolecular forces for liquid and gases become equal and liquid can expand without any restrictions. For small temperature differences, the variation in surface tension with the temperature is linear and is given by the relation, that is Tt is equals to T naught into 1 minus alpha T, where Tt, T naught are the surface tensions at T degrees Celsius and 0 degrees Celsius respectively. And alpha is nothing but it is the temperature coefficient of the surface tension. For example, we can take the hot soup taste better than the cold soup, and machinery parts get jammed in winter. And second one is the impurities. The presence of impurities either on the liquid surface or dissolved in it considerably affect the surface tension depending upon the degree of contamination. A highly soluble substance like sodium chloride, when dissolved in water, it will be increases the surface tension of water. But sparingly soluble substance like phenol, when dissolved in water, it will be decreases the surface tension of water. The surface tension decreases with rise in temperature. The temperature at which the surface tension of liquid becomes zero is called a critical temperature of the liquid. So next comes to the viscosity. The definition of viscosity. Before going to define the viscosity, here we have to know the term, that's a viscous force. So it is the force between a body and a fluid moving fast in a direction so has to oppose the flow of the liquid or fluid past the object. In particular, the force acts on the object in the direction in which the fluid is moving relative to it, and hence opposite to the direction in which it is moving relative to the fluid. So viscous force is an analog in fluids of the force of friction. And now comes to the viscosity. Viscosity is defined as the measure of the resistance of the fluid to a gradual deformation by shear or tensile stress. In other words, Viscosity describes a fluid's resistance to flow or the opposition to the flow of the liquid. Simply put, we can say that honey is thicker than water. In turn, honey is more viscous than water. The viscosity of a fluid is measure of its resistance to deformation at a given rate. Viscosity means the thickness of fluid refers to how resistant a fluid to movement through it. Water has a low or thin viscosity. For example, while honey has a thick or high viscosity. The law of viscosity has important uses in such areas as inkjet printing, protein formulations and injections, and even food and beverage manufacturing. So the viscosity formula is often expressed using Newton's equation, that is F by A is equals to N into dV by dr. When F represents a force and A represents area, so force per area or force divided by area is another way of defining viscosity. dV divided dr represents the shear rate or the speed of the liquid is moving. The eta is constant and equal to unit equal to 0.00089 Pascal second, which is a dynamic viscosity measurement unit. Viscosity may seem of minor importance in daily life. It can actually be very important in many different fields. For example, lubrication in vehicles, cooking, manufacturing, and medicine. So now comes to the point, that is there are two types of the motion in the viscosity, that is streamline motion and the turbulent motion. So consider streamline, turbulent flow and the laminar flow. Streamline flow, we have observed that water flow from is a tap has a smooth texture when a flow rate is low, but the flow rate is increased after reaching a certain value. Voids and disturbances can be seen in such a situations. If you introduce a stream of ink, the flow is smooth, the ink flows without mixing with the other layers. Whereas if it is introduced in the case of turbulent flow, we can see the mixing of the layer of ink with the other layers of the water as shown in the figure below. In this section, we will learn about the first kind, that's a streamline, or we can say that it's a laminar flow. So this is the laminar flow, this is the turbulent flow. And this is the turbulent flow. Turbulent motion is nothing but is the speed of the fluid at a point is continuously undergoing changes. Means irregular eddies are formed. That's a vortices. It will be formed. So means there is no regularity in the flow of the liquid. In both magnitude and direction, it will be changes continuously. Particles of the liquid mix continuously, and magnitude and direction of the liquid at any place change randomly. This type of flow is called as a turbulent flow. Turbulent flow is changing, and hence it can never be said to be calm, steady or unchanged. Characteristics of the turbulent motions are layers of the flow of fluid are not seen in this figure. The layers of the fluid is not parallel. They will be moving in a randomly, and they are not parallel to each other. And velocity of the particles of the fluid in turbulent motion is always different in different places. And when velocity becomes very large, lines of flow form and eddies or vortices. And turbulent flow always becomes random. So consider this one. See here in this figure, the water will be flowing out of the jet, means here the motion will be a random. It is not a regular, and velocity is not a constant. So magnitude and direction will be changes. So this is about the streamline motion and also the turbulent motion. Thank you.